Hello dear students, welcome to a new algebra lesson. Today we'll be talking about the continued proportion. Let's start our session. If the quantities A, B, C, and D are said to be continued proportion, and also if A over B is equal to B over C, where A is called the first proportion, B is called the middle proportion or the mean, and C is called the third proportion, then B equals plus or minus the square root of A times C. So remember that the middle proportion or the mean is equal to positive or negative square root of AC. A is the first proportion and C is the third proportion. Let's now go and check the first example. The question here is asking us to find the middle proportion between each of the two quantities, 5 and 20. We've just said that the middle proportion is equal to positive or negative the square root of their product. So it's equal to positive or negative square root of 5 times 20, which is positive or negative 10. Another question. How can we find the middle proportion of these two quantities, 2 square root of 3 and 6 square root of 3? Again, as we said, the middle proportion is positive or negative square root the product of the two numbers. So the middle proportion is positive or negative square root of 2 root 3 times 6 root 3, and the result that we will get is positive or negative 6. Example 2, the question here is asking us to find the third proportion between each of the two quantities, 6 and 12. So we're going to let the third proportion that we're looking for is x, then 6 over 12 is equal to 12 over x. By cross multiplication, you will see that x equals 12 times 12 over 6, and the result is 24. Here we have two very important notes. If the quantities A, B, and C are said to be on continued proportion, meaning if A over B is equal to B over C, this is equal to M, then B equals C times M and A equals B times M. We have just said that B equals C times M. So in A, we're going to replace the B by Cm, then A equals Cm times M, which is Cm squared. So here in the continued proportion, B equals Cm and A equals Cm squared. What if we have 4 quantities? If the quantities A, B, C, and D are said to be on continued proportion, meaning if A over B is equal to B over C is equal to C over D, for sure this is equal to M, then the C is equal to dm and the B is equal to Cm, which means it's dm squared, and the A is equal to dm cubed. If we check here in example 3, if B is a middle proportion between A and C, prove that 4A squared minus 3B squared over 4B squared minus 3C squared is equal to AC. As long as B is the middle proportion between A and C, you will see that A over B equals B over C equals M, then B equals Cm and A equals Cm squared. From where did we get that A equals Cm squared? A equals Bm and the B is Cm, so it's Cm times M is Cm squared. Now we're going to go to the left hand side in what we want to prove and replace each B by Cm and each A by Cm squared. So here's the left hand side. 4a squared will be 4cm squared all squared, minus 3b squared will be 3cm all squared over 4cm all squared minus 3c squared. If you want to simplify this more, it will be 4c squared m power 4 minus 3c squared m squared over 4c squared m squared minus 3c squared. In the numerator part, if I take c squared m squared as a common factor, so it will be c squared m squared multiplied by 4m squared minus 3, and in the denominator I will take c squared as a common factor, so it will be c squared multiplied by 4m squared minus 3. If we want to simplify this more, the c squared will be crossed out with the c squared, and the 4m squared minus 3 will be crossed out with the 4m squared minus 3. So the result will be m squared. Then we'll move to the right hand side. A over c. A over c, as we know the a is cm squared over c, then the cn over c will be crossed out together, equals m squared. From 1 and 2, you will see that the left hand side is equal to the right hand side. So 4a squared minus 3b squared over 4b squared minus 3c squared is equal to a over c, because they both are equal to m squared. In example 4, if the quantities a, b, c, and d are in continued proportion, that's given, the question wants us to prove that b over b plus d is equal to the right hand side, which is c squared over c squared plus d squared. A over b equals b over c equal c over d equal m. Then c equals dm and b equals dm squared and a equals dm to the power of 3. To prove what the question wants us to prove, we're going to go to the left hand side. So we're going to write the left hand side, and then in the left hand side we're going to replace each b with its value. So it's dm squared over dm squared plus d. In the denominator, if I take d as a common factor, it will be d open bracket m squared plus 1. The d up and the d down are crossed out together, so here it's m squared over m squared plus 1. Let's call this number 1. If we go now to the right hand side, the right hand side is c squared over c squared plus d squared. We replace each c by dm, so this will be d squared m squared over d squared m squared plus d squared. In the denominator, if you take d squared as a common factor, it will be d squared m squared over d squared open bracket m squared plus 1. If you simplify it, the d squared will be crossed out with the d squared, then the result will be m squared over m squared plus 1. And this is number 2. From 1 and 2, you will see that the left hand side, which is b over b plus d, is equal to the right hand side, which is c squared over c squared plus d squared. Example number 5, if the quantities a, b, c, and d are in continued proportion, The question wants us to prove that the cubic root of 5a cubed minus 3c cubed over 5b cubed minus 3d cubed equals a plus c over b plus d. Once they are in continued proportion, then a over b is equal to b over c is equal to c over d is equal to m. Then the c is dm, where the b is dm squared, and the a is dm cubed. Let's now go to the left-hand side. Cubic root of 5, and the a cubed, we're going to replace it by dm cubed all to the power of 3 minus 3 dm all to the power of 3. All of this is over 5 dm squared to the power of 3 minus 3 d cubed. So this is equal to, let's make this cubic root a bit bigger, 5 d power 3 m power 9 minus 3 d power 3 m power 3 over 5 d cubed m power 6 minus 3d cubed. We're going to take the common factors in the numerator and the denominator. So in the numerator, the common factor will be d cubed m cubed, and the bracket will be 5m power 6 minus 3. And in the denominator, the common factor will be d power 3, and the bracket will be 5m power 6 minus 3. So here, the d power 3 and the d power 3 are crossed out together. This bracket and this bracket are crossed out together. So what's left for us is the cubic root of m to the power of 3, which is m. And we call this number 1. In the right-hand side, it's a plus c over b plus d. Then the a is dm cubed plus the c, which is dm, over the b, which is dm squared plus d. If you take the common factors in the numerator and the denominator, the common factor up is dm. So it's dm multiplied by m squared plus 1. And in the denominator, it's d times m squared plus 1. If you simplify this, m squared plus 1 will be crossed out up and down, and the d is crossed out up and down. The result is m. And we call this number 2. From 1 and 2, you will see that the left-hand side is equal to the right-hand side. Then the cubic root of 5a cubed minus 3c cubed over 5b cubed minus 3d cubed is equal to a plus c over b plus d. And now, before we go to the evaluation part, as you all know that once you see the question, pause the video, try to solve the question yourself, and then play the video again to check the solution. The first question in the evaluation says, if B is the middle proportion between A and C is the middle proportion between B and D, prove that A squared over B squared plus B squared over C squared plus c squared over d squared equals a over c plus b over d plus ac over bd. Since b is the middle proportion of ac, then a over b equals b over c. And since c is the middle proportion of bd, then b over c equals c over d. So here, when we go to the left-hand side, the question says a squared over b squared plus b squared over c squared plus c squared over d squared. Then here we're going to replace the middle terms by the product of the two other letters. So here, a squared over, and instead of b squared, we're going to write ac equals b squared, we replace it by ac over, and the c squared from the second one here, we replace it by bd equals the bd over d squared. If we simplify this, this a will be crossed out with this power 2. So it's a over c equals ac over bd equals, and here this d will be crossed out with this power 2, so it's over bd. And this is what the question wants us to prove. So as you can see here, the left-hand side is equal to the right-hand side. Next question. If 5a, 6b, 7c, and 8d are positive quantities in continued proportion, let's prove that the cubic root of 5a over 8d is equal to the square root of 5a plus 6b over 7c plus 8d. Once these four quantities are in continued proportion, we will write that 5a over 6b equals 6b over 7c equals 7c over 8d equals m. Then 7c equals 8dm, where 6b equals 7cm, which is equal to 8dm squared, and the 5a equals 6bm, which is then 8dm cubed. Let's keep this aside to help me proving what the question wants me to prove. To start proving, we go to the left-hand side. And the left-hand side, it's a cubic root of 5a over 8d. Replace the 5a by 8dm cubed over 8d. So the 8d is crossed out with the 8d. So this is the cubic root of m cubed, which is m. When we go to the right-hand side, it says square root of, and instead of 5a, we're going to write 8dm cubed plus, instead of 6b, we'll write 8dm squared over, instead of 7c, we'll write 8dm plus 8d. Let's take the common factors up and down. So the common factor up will be 8dm squared and it will be multiplied by m plus 1. And in the denominator, it will be 8d multiplied by m plus 1. M plus 1 up and m plus 1 down are crossed out together, and 8d up and 8d down is crossed out together. So what's left for you is a square root of m squared, which is also m. If I call this 1 and I call this 2, I can now say that from 1 and 2, the left-hand side is equal to the right-hand side. By solving this example, we came to the end of our lesson today. Thank you very much. Best of luck.